Creating an EC2 instance, key pairs, and security groups, part 2. Well, I'll say about half of that is true. Key pairs we already talked about. So this is going to be a nugget fully on security groups. So I'm just going to block these guys out. That was everything in the last nugget, talking about kind of our bearings, where we are at, and then how the key pairs work in the Windows and Linux world. And now we're going to dive into configuring security groups, which is your firewall to AWS. Most people are first exposed to security groups when they're creating an instance. It's just one of the last questions it asks you, and people look at it and go, oh, okay, add this. Okay, fine, finish. And they just go on. And that's fine when you first get started with EC2. But you want to get a grasp on it quickly, not only for the security permissions, but once you do this, let me show it to you. I'm going to launch an instance. Let's go in here. We'll grab Ubuntu. That's fine. It's amazing how fast you can create an instance. And here we are. This is last question before we get to the review, is what security group do you want to be in? Now, the name really says it all. What is a security group? It is a setting that applies security to a group of instances. I had to say that slowly just so I say it right. It is a setting that it supplies security to a group of instances. So let's get our definitions down. What is a group? What could I just have one server in a group? You sure can. I could create maybe a security group called JC's SG. Security group. And I'm going to say that's applied to this one Ubuntu instance, and it only applies to that. I'm a security group in myself. Or I could apply JC's SG to a whole bunch of instances as I generate them. Instead of going through and creating a new group, if I did that, once I created, I could say that's JC's SG, security group. And I'll create this for you in a second, you'll see. Now, here's the trick. And let me jump straight down here. Something you really want to be aware of. Once you assign an instance to a security group, you can't change it. So that means when I put an instance in here, it automatically gets all the same security permissions as everything else in that group. So if this security group is allowing, and I should probably dive into this, is allowing, we'll say HTTP, which is actually TCP port 80. It's allowing HTTP in, then that's allowed to all those servers, and you can't change that without VPC, which we'll talk about virtual private cloud later on. But that's just the default. Now, it's kind of big because once you create that instance, it's there. It's in that security group permanently. Now, let me just put a personal aside in there. This is something I expect to change someday. When I first saw it, I thought, really? And I've with people that I talk to, they're as well like, wow, that's really, wow, really? It's just one of those, like, not something that you would expect. So I'm assuming someday, now this is just, again, personal aside, Jeremy's assumption, someday AWS will change this setting to where you can move instances between security groups. But at the same time, it's been years and years and years, and here we are. So you want to know which one you're assigning it to. So let's define them a little bit more, put a little more meat around them. When you create a security group, click on Create Security Group. The basics is really just assign a name. So I'll say just for this, JC's Security Group, and we'll put a description. This is Jeremy Chara's first security group. Now I go in and add my rules. Now, if you don't know much about networking, this may look a little foreign to you. If you are a networking whiz, you'll be like, I got it. It makes sense. So, for instance, we have our list of protocols. Now, Amazon has said a custom TCP or UDP rule or ICMP rule. These are the three most common protocols in the world. I mean, just about everything uses these three protocols. There are others. For instance, there are routing protocols like OSPF, EIGRP that are a protocol in themselves, but we're not going to talk about those because not really applicable here. Most of our server traffic will be on these. So I could say I want to create a custom TCP rule, and I'm going to say port 80, which is HTTP, is allowed in. But Amazon has said, you know what? There are some common ports like HTTP that we could just say, why don't we just make a quick shortcut? Or, for instance, managing a Windows server, RDP, Remote Desktop Protocol, very common one. So let's say let's use one of these quick big jumps right here. I want to allow Remote Desktop wait a sec, I'm creating Ubuntu, right? Then it would be SSH. Ubuntu cares nothing for RDP. That's Windows. So Ubuntu, I'm going to say SSH from a source of What do you want? Now, by default, you can see the selection there is anybody in the world. This is your way of saying essentially any IP address with any specificity. Nice word I'll just make up there on the subnet mask. So that says anyone in the world. Now, if I want to get more restrictive, I could say, well, I just want to allow SSH from my company network, which has IP addresses starting with 68.55.77.2029. Well, actually, I wouldn't put starting with. I'll put 0/24. Good grief, I got to look at where my keys are at. 24. So that says anybody in that subnet, anyone with an IP address starting with these first 3 octets is allowed in. So you could do that, or I could get specific. For instance, I could go to Google and type in what's my IP address, and Google in all their glory will have a little shortcut. This is, please don't hack me. Can I say that? Let me just say that. Don't try to break in my house because I'm a nice guy. So I could go in here and paste that in and say /32. /32 is a full host mask. Now, if you haven't gotten into subnetting, it's like what, huh, what? I mean, /32 is the same thing as 255.255.255.255 on a subnet mask, as specific as it could possibly be. And I could say I want to name that. This is SSH from my house. Add rule. I've added my first rule in there. Okay, or maybe let's add another one. Now I've added SSH. I'm allowing SSH from my house. I could make a quick one right here. HTTP. I want to allow web traffic from anyone. We'll say web traffic from all. Add rule. You can see it, and this is building a firewall. Now, security groups, let me flip back here, are for inbound filtering. They do not do outbound filtering. And let me go to this default and discuss this real quick. The rules of security groups. By default, if you just say go into the default security group, there will be no inbound access allowed. So let's draw a little server here. Default. We put them in the default security group. There is nothing allowed inbound. Everything allowed outbound, and everything is allowed within the group. So what does that mean? It means if I start adding additional instances in this same security group, they will all be able to access each other fully. Now you'll find out you can actually create multiple security groups and control access between them. I'm going to show you that in just a second. But for now, this is the default. So if I had a bunch of servers that I assigned to my I forgot what I named it, JCSG, or Jeremy Charles Security Group, then they are able to access each other fully able to go outbound, and then these are my inbound restrictions that I'm setting up right here. The fact is, default security groups don't do outbound filtering. I cannot control what leaves my server. And most of the time, I'll say for most people, they're like, good. It's my server. I don't want to restrict my server from getting to the internet or getting to something else. And maybe I restrict who can come to my server. That's good. That's inbound. But I don't want to restrict my server. But there are other people who would say, I do want to restrict my server. This server should never respond on a port other than this because that's a specific function. And I want to be super secure. That's where you bust out VPC. Virtual private cloud gives you full control over everything. The networking, the inbound, the outbound, everything. So again, we'll talk about VPC later on in the series. But for now, we're just talking the normal day-to-day security groups. Okay. Back over here. So I can create, I just did HTTP. I can also create a custom TCP rule. For instance, maybe I want to run, I don't know why this just popped in my own head. Maybe I want to run my own custom World of Warcraft ports server from AWS. I want to pay to run my own World of Warcraft. Okay, so World of Warcraft right there. Configuring your router for use with World of Warcraft. So Blizzard is telling us that World of Warcraft requires that TCP ports 119, and so right here we've got it right there. Now I don't know if this is for World of Warcraft client, but let's just say it's to run a World. Okay, now my own curiosity. World of Warcraft server ports. Got to find it. So how to set up a public WoW server. I don't even. I'm scared. I'm doing this without a net, guys. If something pops up, just pretend like you don't see it. These websites scare me. So firewall. Hang on, I gotta pause this. Aha! I found it. So to run, see, I told you, scary. To run a World of Warcraft server, they're saying real MD and whatever that is takes TCP 3724. World of Warcraft is 8085. So let's do custom 8085. This is my WoW server, and I'm saying the world can access WoW. World of Warcraft port. So we'll add that in. You see how easy this is? You just say, okay, real MD, 3724. Paste it in there from real MD. I don't know what that is. So I'm going to add that in. Again, these are just services. So now the world can come in on these ports. Or, again, you can. I don't want to tread the same ground. You can see where I'm going with this. Now, one of the things that I like doing is always allowing ICMP. Now, all ICMP is pretty big, but that for instance allows me to ping my server, allow my server to respond to my pings. To sometimes ICMP unreachable. Now there are security ramifications if you allow all ICMP. So you might just want to go in here and say, well, I just want to allow specific ICMP messages. For instance, echo request is what I would want if I wanted to be able to ping my server. So again, we set up our firewall with each one of these. Let's just say allow pings. As this. You see what I'm doing here? So it's dividing it. I see ICMP is one protocol, TCP is another. Continue. I now have my JC SG in it, and let me go back. You can see it right there. I've now got my JC's SG security group created. Now this new instance that I'm creating, this Ubuntu server, is going to adopt that security group. Now you'll see, and right here you can see my Ubuntu servers being generated right now, but TSO1 is assigned to a security group. Notice they even have an option here for change security group. That's grayed out. I can't click on it. That's because that only comes alive if I'm using VPC, the virtual private cloud, to where I can control all of the network. So once again, this guy is in a security group. I can see it right here. Quick Start 1, which is one that AWS generates for me if I just don't put anything. It says, oh, well, we'll do a quick start, which it recognizes it's Windows, and by default, it allows remote desktop protocol, so I'm able to get to that Windows instance and manage it. Now, I have to say, I've been pretty impressed with the way Amazon has applied their security groups, because it's an amazingly simple way of doing it. I mean, firewalls are pretty hairy beasts. They get pretty complex. And so just with the base security group, you can define some pretty amazing inbound restrictions or permissions to your instances without having too much knowledge of it. But they have moved the ability to do more complex networking and the ability for more complex firewall rules over to VPC. So the ability is still there, but it's just, from the get-go, it's a pretty simple setup. Now, there is definitely some stuff to be aware of here. First off, when you begin moving into multiple security groups, which a lot of people do on accident by default because they don't fully understand what they're doing when they're creating the instances, and they create one security group per instance. When you move into multiple security groups, you have started to go into a land of restriction. By default, and I mentioned this, within a group is allowed full access. So anything that you add to the same security group is good. If you want permissions between security groups, you have to allow them. By default, security groups cannot speak to each other than, the broad rule. So for instance, if I said everybody can come in on web traffic, then sure, my security group A can access security group B using HTTP web traffic. So there's those kind of rules, but you may want to allow all permissions between security groups so they can have full access as well. So I want to show you how you can go about this manually, how you can manually create security groups, modify security groups, and set those permissions. So I jumped down here to security groups, and you can see that I've got the default group. There's my JC's security group right here. And I can see all of the permissions that I just set. Now, one of the things I've noticed is, first off, this name field is a new thing. You want to know how I know? Right there, it says new. And actually, it didn't used to be there. And I've seen some inconsistencies to where when I'm creating a security group with an instance, sometimes it loses the names. Like you remember, I put in all the different names here for World of Warcraft and all that, and now they're not there. And that's, I'm sure, a bug that will be fixed by time you get here. But for instance, I could come in here and say, well, I want to name this HTTP for all. And and say check, and now I've got a name there that I can reference. Little notes, just like I did when I was going through this, but now they'll actually stay. So I'll put World of Warcraft and so on. So I can go through and modify the names. I can delete them. I can say, well, I don't want to allow World of Warcraft anymore, and as soon as I hit apply, it's going to remove that out of there. I don't have the ability to modify things like the source and the port. If I want to do that, I would just delete the rule and create another one that had the correct port and permissions. It's not that big a deal to create one, so they said, why make it modifiable? So let me apply the rule change. You can see World of Warcraft is now gone out of there. So let's say I wanted to allow permissions from, for instance, JC security group to the Linux default group. So Linux default has the, actually, sorry, before I go there, I was going to say, hey, how do you create a new one? Let's say I just wanted to create a new one on the fly. Maybe I'll do CBT group, whatever. VPCs, if I had a virtual private cloud set up, it would show up here, but I don't, so I'll just create the normal one, and I've got now CBT group where I can go in and modify the permissions here. There's nothing in it, so I could create a SSH from everyone, add the rule in there, and do whatever it is I want with that CBT group. Now we know that we can't change the security group assigned to the instances. It's grayed out, so this security group would be for new instances that I'm creating. I would just assign them in there. So you can see why it's good to know this kind of stuff coming in, because it's very easy to just start creating a bunch of security groups, and then you're stuck with all these security groups. You've got to assign permissions between them because you can't reassign them. You can't say, oh, well, let's take off that security group from the instance. Now, if there's nothing assigned to the security group, I can delete it. I can say, you're done, CBT group, but they do prevent me from restricting things that things are assigned to. So, and that would make sense. You can't pull the fabric out from underneath one of your instances. So now let's talk about defining custom rules between groups. So let's say I wanted to allow the Linux default group, which is one of my Ubuntu servers, to have access to JC's security group. I can come in here and say, I want to create a custom TCP rule. I want to allow all TCP. Let's go there. I want to allow full access from one security group to the other. So the source, instead of saying everybody, that'd be scary because that says the world has access, the internet included. I would actually type in Linux. Oh, wait, it's case sensitive. Linux. There we go. Linux default, and it pulls it up for me. Now, it's smart enough to say there's actually a little code word behind the scenes that I'm assigning to that security group. We see the actual name right here. I can go in and add a few more things here to see the group ID, to see the code name, and so on. But it will fill it in for me. So I can just use my user-friendly names here. So I'm going to say I want to allow all TCP traffic from that Linux group, and we'll say allow the Linux guys. Add rule. And now I've got permissions that are allowing another security group to come in and access JC's security group. See how that works? So it's pretty simple, but keep in mind, doing this is still not as good as having the full access, meaning I've got full control here where this guy can fully access him and fully access him. For instance, just saying all TCP is allowed between these security groups is good, but what about UDP? What about ICMP? What about IPsec? I mean, there's protocols that are not represented here in this list. OSPF, EIGRP. I mean, sure, they're definitely not used that often, especially in the server environment. But there are things other than TCP, UDP, and ICMP. So having that, the ease of putting things in the same security group is very nice. So at this point, we've seen a lot of security group pieces. It's some facts, some figures. Here's how you configure one, name it, set it up, add a rule to it, and so on. But I want to take all those pieces and put them into one good practical example. So here's something that happens all the time with Amazon AWS. We've got somebody hosting a website. They're running it on IIS. They want those web servers to be public facing. Those are the web servers that feed different, it feeds their customers. Their customers come surf the web from those servers. Now, those servers are typically not put in the same security group as the database servers that power them. Databases holding all the facts and figures for those websites, like what is your account balance, or how many sales have you had, or whatever the service is. You don't usually put them in the same area, simply because, well, number one, it makes them a little more exposed to the internet. You're now saying, okay, people can come in here and access not only IIS but get straight to my database servers. How about no? They don't belong there. The only thing that should be accessing my database servers is the IIS web servers. Likewise, not to say this would ever happen, but imagine with me for a moment, Microsoft has a security vulnerability, and somebody compromises the IIS web server and takes over it. Well, now if the database servers are right in that same security group, you're doomed. IIS can now be used as a launch point to start attacking and taking out those database servers from there. So we want them in a filtered separate group. And you can kind of see the flow here. Let me just clear off my gibberish. The web has access to IIS, and IIS has access to the database. But not just full access. Take a look. I've got from the internet to IIS, pretty much web surfing protocols, HTTP and HTTPS, and just for fun, normally you wouldn't do this, but we'll allow remote management, RDP from anywhere in the world to access this. Now, I will say there are a lot of people that do that, so I got to bite my tongue when I say most of the time you wouldn't. Scary. Scary to allow full RDP access to a server that's connected to the internet, because there are all kinds of scripts running from all over the world where people are just checking for open it's a TCP port 3389, looking for that port, and when they find it, they'll just start barraging you with I'm not thinking denial of service, but a brute force attack, to where they're trying different usernames, different password combinations, and at best case they're just causing extra load on your server. At worst case, they find one. They can essentially sit there and try it all day, all night, tons of passwords every single second, because they have a script running. It's not like some guy sitting there typing things in. So not the best idea to allow RDP access to your servers, but we're doing it here. Now, once you get here, from IIS to DB, now remember, everything security group-wise is inbound filtering. So when I say from IIS to DB, don't be thinking outbound filtering. That's not what security groups do. That'll come later when we talk about VPC, Virtual Private Cloud. For now, we're mainly talking about inbound. So a better way to think about that when you see that is saying, okay, the database server is only allowing inbound from the web servers, MySQL, that's TCP 3306, and then all ICMP. Now, database servers are a trusted source for us, so we're going to say they can pretty much use anything that they want to access the web servers, because if there's no chance, unless it's an internal person, of our database servers getting compromised. You see all those pieces in place? Okay, so let's get into the management console. So let me slide this over into the window. Get this guy's size just right. When you have kids, everything changes. You can't even say things like just right anymore without thinking Goldilocks and the Three Bears. So I'm going to come over to the security group and click on that, and I'm going to add a new one. So I'm going to create one. So this will be for our web servers. That's piece number one. So I'll say web servers. Description, you got to type one in. So MSFT IS web servers. We're not using any virtual private cloud. That's later. So I'm going to click on create, and bam, we've got our security group right there, web servers. Just came up, and let's also create one for the database. So I'm going to do the database servers. We'll do MySQL DB servers. Create that. Bam, we got that there. Okay, so we can see, just as before, I've added a few things to the field. So we see even the group ID. We see the owner. That's the little number assigned to my account that created that security group. But nothing's actually inside of these yet. That comes later when we add the servers. So from there, now I want to start doing my restrictions. So from the internet to IIS. Okay, so internet to IIS. Immediate. Let's go with our mind. So I'm going to go to web servers right here. Inbound restrictions. This is a custom TCP rule. Now, there's of course many ways I could approach anything. There are good news, well-known rules here for HTTP, HTTPS, and RDP. All three of the protocols that we were wanting for IIS. So I'll go that route for this one. We'll do the custom TCP rules in just a second. So let's say HTTP. Now it's saying, okay, what is the source? This is where you get into a little IP addressing. 0000/0 means anyone. That's like the least specific subnet mask IP address combination you can have. That matches everybody in the world. If I wanted, maybe there was a certain office I wanted to be able to access this. I could say, well, that office is on CenturyLink, and CenturyLink uses the IP addresses 208.50.0.0/16. Again, getting into, without diving fully into subnetting, the /16 represents each one of these octets, 208.50. You might be saying, well, how's that work? Well, it's all binary. The /16 is the number of ones in your subnet mask in a binary. And if you're not too familiar with subnetting, just remember that each one of these numbers represents 8 bits. So 208, that represents 8 bits. 50, 8 bits. 0, 8 bits. 0. So essentially every dot separating this is 8 bits. So when I say, if I were to do /8 here, it wouldn't make sense to type the 50, because it would be the same thing as saying anything starting with 208 is allowed to access this using HTTP. Or if I were to say /24, which is a common one, that would say any IP address starting with 208, that's 8, plus 8, that's 0, plus 8, that's another 0. So anything starting with 208.0.0. whatever. I don't care what's in that last octet, because I'm only looking at the first 24 bits. Does that make sense? So if you aren't super ninja-like on your subnetting skills, just remember that each one of those are 8, and you're well on your way. You shouldn't typically get into too many custom subnet masks with this. But that allows me to filter anything. So now it makes sense. When I put 0000 and then do a /0, that's pretty much saying the source is anything, and I don't care about anything. That little, meaning I could type whatever I want in here, but the /0 says, but none of it's relevant to me. Good. So I'm adding the rule. So I now am allowing HTTP. Let's get another one. HTTPS, it's also from anyone. Add the rule. Because I chose HTTPS, not HTTP. Add the rule. Down here, Remote Desktop Protocol, RDP, add the rule. Boom. We now have anybody being allowed to access these IIS web servers on those three. Good. Let's flip over to the database server. So I'm going to click on that. Pretty much nothing here. Let's look at our config. So we're saying IIS to DB. So the database is filtered. I don't want to allow the world having access to that. So all I need to do here is say, okay, well, I'm going to create, well, good grief. Amazon thought of everything. Let's create a custom TCP rule, because maybe we don't trust the MySQL Amazon mapping. So I'm going to say 3306 is my port number. The source is the web servers. So as I'm typing, I could type in that security ID, which is pretty hairy, or just start typing in web servers, and AWS is smart enough. It goes, got it, I'm adding it for you. So bam, just like that, we've got now MySQL being allowed from IIS, as well as all ICMP. So I'm going to say I want to allow all ICMP also from the web servers. Good. Do you see how these pieces are fitting together? Come on. You've got that little warm fuzzy feeling right now. You're like, I'm getting this. I'm getting this. Now remember, if you're a traditional firewall person, a lot of times you're thinking, okay, well, wait a sec. If they access me on port 3306, which is that MySQL port, well, won't this guy reply to whatever source port, and that'll be a denied? Well, again, remember, security groups, what direction? Inbound only. So we don't have to worry about the outbound replies coming back getting knocked down, because that's not what the security group is trying to filter. So its beauty is in its simplicity. It's so simple. Now when you get to the VPC, you have a lot more options, so you have the flexibility if you want it, but most people don't want to filter what their database servers can talk to from an outbound perspective, or their web servers can talk to from an outbound perspective. They're more concerned about who can get to those servers. It's all inbound. All right, so the last piece now is database to IIS. I want to allow all TCP, all UDP, all ICMP. Because remember, from an inbound perspective, once I separate these security groups, IIS web servers do not trust the database. It's easy to forget about one of those. So let me jump back here. So we've got, okay, web servers are filtered, database servers are filtered. So I'm going to add more to the web servers now and say I'm going to have all TCP traffic allowed. You know where I'm going with this, right? Database servers. Bam. Add the rule. All UDP traffic from database servers. Bam. All ICMP. Database servers. Bam. You know, one last thing. So hang on. That's it. We're golden, right? We've got this configuration. I can go by and say, okay, got it. Every single one of those are taken out. I had a revelation yesterday. My friend invited me to a drum corps, which if you've never gone to a drum corps before, they are intense. I mean, it's high school kids, so you know you're thinking, okay, well, high school kids, yeah. I mean, these guys are good. It's like a marching band on steroids, the biggest marching band you've ever seen. All these different people fly in from all over the world to compete, and these kids are so intense. I'm watching. They're doing like one group dressed up like ninjas. Like all the drummers were in ninja outfits, and the music first off is amazing. Every group is amazing. But I turned to my friend and I said, you know who's gonna win this one? It's the people who do it with the most drama. The people who have the drama around. And I'm watching these ninja guys, and they're beating the drums, and like every now and then you would see them just kind of, their muscles would tense. They'd be like, ah, yeah, and they jam on the drums and all that kind of stuff. And you're going, how does this have to do with AWS? That's where I'm getting to. If you're configuring AWS, every single time you add a rule in here, be like, ah, yeah. Add it in there, just bam. Every time I do it, I'm just like, there it is. You know, the more you can get into this, the more drama you add to AWS, the more drama you add to any career in your life, the more you're gonna love it. It's gonna feel fake at first. You're gonna be like, okay, I'm not really excited about adding the web rule, but you will be. I set up a voice over IP server yesterday. I called a friend to test, and he picked up the line. I'm like, oh. And he's like, what? I'm like, the ringtone. It wasn't a fast busy. It was a brrrr. And he's like, I love that about you, Jeremy. He's like, nobody else in the world do I know gets excited when they hear a phone ring. I'm like, oh. I was like, it was, after hearing that busy signal all morning, it was like music to my ears. I felt good, you know. And so anyway, I'm just telling you, you are gonna love AWS if you are a ninja like my drum corps guys. So that builds out the practical scenario. Okay, so wow, I just had a revelation here. I went back to this slide. I'm like, okay, well, let's wrap up security groups. We've talked about it enough, and I just said, okay, where are we right now? We're in a really good place at this point. I would say if you were going through this series in order, you've arrived at a major milestone. You're there. You're good with EC2 at its core, to where you know the pricing structures, you know the instance types, you know the availability zones and redundancy and how that works, and now you know about the key pairs, the security settings, the security groups, how to filter inbound access to your machines. You have the knowledge. You could right now just say, okay, I'm good. Let's start moving our company to Amazon. You know, I was thinking AWS and Amazon all at the same time. Amazon EC2. And start seeing some stuff happen. Is there more to learn? Absolutely. There's a huge amount, but I would say this is a pretty massive milestone. So looking back at security groups specifically, you know the global rules of the security groups, which is to allow no inbound traffic. If you don't configure a security group, it's going to assign a default, which is no inbound traffic from anything outside of that security group. All outbound traffic is allowed. Remember, security groups inbound only. All outbound's always allowed. And then all of the instances that are in the same security group have no problem talking to each other. No filtering on that at all. So once you've got an instance in a security group, it is locked there. It's not something that you can easily reassign unless you move into VPC, which I keep saying we're going to talk about, so we will get into VPC. And then we looked at assigning the rules. We even looked at CIDR notation. That was the IP address notation, like 10.0.0.0/8 and those kind of settings. That's called CIDR. Using that to filter the security groups, allowing specific TCP UDP ports. I mean, you are now AWS firewall administrators, which is pretty powerful. So I hope this has been informative for you, and I'd like to thank you for viewing.